With serial rapes, we can identify the attacked place where the woman was abducted, the shopping center. Where was she taken to being raped, and where she was released. So all these have a latitude longitude point. So we can then take those locations, put it in the mathematical model, and then we can work out the highest probability the person could be found. We can look for missing persons and things like that using LiDAR and the GIS and various algorithms to strip the vegetation, and then we can look at indentations on the soil, on the surface, and if it's rectangular shape, it could indicate a shallow grave, because after time the soil settles, so it leaves a distinct pattern, and then you can look at that. The other one that I worked on was a assassination case at waterfront in Cape Town, where the guy was with a sniper shot the person, and then could track the sniper's movements based on his cell phone records. How did he came to the waterfront, how he did the stakeout, where was the best place to do a shot.
In a world where Africans have lost their roots, it has become of vital importance to document our ways. In an effort to reverse the brainwashing of the past, where we were made to believe our ways are demonic, we are pressed to create dignified and respectful platforms to unpack our spiritual ways. The views and opinions expressed in this episode are those of the guest and do not necessarily reflect the beliefs or position of this channel, its hosts, or affiliates. This podcast is a platform for open discussions and exploration of various perspectives, including controversial and unconventional ideas. We encourage viewers to think critically, do their own research, and form their own opinions. The content is for informational and entertainment purposes only and should not be taken as fact, advice, or an endorsement of any specific viewpoint. Viewers' discretion is advised. This episode is brought to you by the University of South Africa.
Moya light, Moya bright. Welcome to another episode of Moya Podcast, where we're collaborating with the University of South Africa so that we can learn a bit about which industries we can get into, learn more about the university, and just like have a human element of what it is. You guys were young, we're trying to figure out, okay, what are we going to study next year? And, so that you find what your interests are, we're helping you along on the journey. Today we've got Professor Peter Schmidt. We're going to speak about forensics and things like that and crime. And since we've got the Madlanga Commission going on, we're learning a lot. Welcome, Professor.
Thank you.
Thank you so much for coming. So please tell us exactly what it is that you do.
Thank you very much. My speciality is actually Geo Profiling. So what I do is I take cell phone data records and I analyze it, seeing how people moved through time and space and how they communicated with each other, and also then construct it on a map showing to the prosecution and the investigating officers from SAPS how these people moved through time and space and when did they communicate to whom and where were they located. Then I corresponded with other data like video footage, what the location is, where the camera was, so if it photographed a motor vehicle's number plate and so on, or cell phone towers that were triggered, where the locations are, or other information that they have provided to me that can be mapped. I did also a course in geoprofiling of serial murderers and killers and rapists. And one of the case studies I did when I did the course in Canada was Eileen Wuornos, which was featured in the film Monster that was played by Charlize Theron. We did work on the real case as one of the case studies that we investigated. Okay, that was not after the fact, but it was how do we piece evidence together so that we know that this particular incident is linked to a specific person. The serial killers or serial rapists normally, with a serial rapist, the victim survives, so we can interview the victim and know where the incident happened, where she was abducted, where did the rapist take her, and where did she was raped, and where was she released. We use all that information trying to figure out where's the highest probability where we can arrest the guy. The same we do with serial killings, but it's more gory, unfortunately. But the serial killers normally leave little tokens at the bodies and so on. Then you know this particular body belonged to this particular serial killer because there's certain things lying around like coins on the eyes, things
So
like
they
that.
leave signatures?
Yes, they like to say that is my body, I killed that person. So we use that information to try to determine also where's the most probable location where we can arrest the guy. Then what we cannot say house A at address so and so, but we can say the highest probability are these 2 or 3 street blocks, and then the police can go with the psychological profile of the serial killer that was done by a psychologist, and then criminal psychologist, and then also then they take a DNA swab kit with them, and then they knock at doors and then say, sir, with a warrant, we want the DNA swab, and then they swab everybody in that particular area, and then they compare the DNA with the DNA found on the bodies and so on, and then if it's a match, they arrest the guy. So what I do is with the geoprofiling is the distribution of bodies may be over several square kilometers. Some instances, on one case that I worked on, it was over 100 square kilometers. Now where are you going to find that person? But with the geographical profiling, we could narrow it down to 2 street blocks, and in one of the street blocks, a guy was arrested.
Okay, so you're going to have to speak to us like we are in grade 1. Okay. So first we want to know what geoprofiling is, and then we've got lots of time, Prof. So please don't feel rushed, like you have to please break down, unpack everything for us, even when, how does a case move, like the whole process?
All right. If the body is found...
First, geoprofiling.
Geoprofiling. Okay, geoprofiling, geo means geography. So we look at location, all right? Now what we do is we take a GPS, we plot the points where the people were found. Okay. Let's stick to a serial killer. And then we look, based on the psychological, the criminal psychologist looks at the crime scene because they can see all these little telltale things and so on, which is important for them to build a psychological profile of the serial killer. What I do is I take the location, latitude, longitude coordinate, and if there are 5 or more victims, I can start putting a little bit of mathematics to it, and then I can try to figure out where's the highest probability to find the person. So there's a little bit of maths involved. Yeah.
Okay, so what's the process?
And the process is as follows, all right? There's a body found. The police get involved and they open up a murder docket. Suddenly there's another body found. Then another body found over time. Now, serial killers have certain behavioral patterns that we look into based on what we call it's an environmental criminology routine activity theory. So what we do is so to a crime to happen is the criminal, the serial killer, the process works as follows. He dreams about a certain person, whether it's a male or female. Let's for argument's sake, it's a female. She has a certain complexion. She might be white, blonde hair, certain build, and so on. He fantasizes about her, what he's going to do with her and all that kind of stuff. Sorry about the gory detail. And then he will go and look for a suitable suitable victim. So his routine activity will maybe involve a shopping center. Her routine activity will also include the shopping center because she needs to buy goods or clothes or whatever. And when the two intersect, then he will follow her. And then when the opportunity arises that it's safe for him to attack the victim, then he will attack, and then he will take her away and do what he wants to do with her. So with serial rapes, we can identify the attacked place where the woman was abducted, the shopping center, where was she taken to being raped, and where she was released. So all these have a latitude, longitude point. So we can then take those locations, put it in the mathematical model, and then we can work out the highest probability where the person could be found. Yeah.
That's
so there's
incredible.
geography, study geography, and mathematics, and you can do little fun things like that.
That is amazing. Okay, so we're still trying to understand, because we are learning so much in a short space of time about how you guys, is there technology to do all of this?
Yes, there's there's a specialized program. There are several that you can get, but it's normally open for law enforcement agencies only. That has the mathematical equations already built in. Some of them you can download. I can't remember now exactly the name for the particular algorithm, but you can download this algorithm and then you use a geographical information system which allows you to display locations. But geographical information systems are a tool that everybody can use. They use it for environmental impact assessments. They use GIS for building placement. They use GIS for precision farming. They use GIS, geographical information systems, for digital twins of buildings, bridges, roads, all that kind of stuff. Anything that has a location which you can map, you can use this tool for. And then you can have various mathematical tools. For example, if you have a elevation model which gives you height above sea level for each little point or squares, a pixel, then you can work out the slope, you can work out contour lines, you can work out the direction of water flows down the hill, you can do hill shade, so you can simulate a 3D model, you can do aspect, which part of the slope looks towards the north, which part looks to the south. If you want to place optimal game lodges, you want to put them at a certain elevation so that they overlook a river where the tourists can sit there and look at the animals. You can work out reach of a cell tower, taking into account buildings, the terrain. So the GIS is a tool that you can use for various things, including geoprofiling.
This is amazing.
So that is one of the spin-offs from geography. You go to university. We offer at the Department of Geography, we have modules that teaches GIS, especially for our environmental management students. But other universities like Pretoria and Cape Town, they have more specialized degrees, but they look at the science behind it. What you can do also with the GIS, you know where the river flows, you know the topography, so you can simulate floods. So on which areas are going to be flooded if you have such amount of rainfall, or if you have a cyclone like what happened in Mozambique, you can determine which communities are in danger of being flooded. You can evacuate them before if there's a cyclone warning. You can also use satellite imagery. You can analyze satellite imagery. You can, from satellite imagery and LiDAR, that's a laser, it's a camera with a laser points that's been beamed back to the camera. then you can get a 3D model of the area, trees, roads, buildings. And we also use LiDAR in forensics. What's interesting with LiDAR is if you fly the LiDAR camera over an area, it shoots out a laser point, and that point gets reflected back. The system will then recognize how long it traveled to that point and how long it traveled back. Then it can work out the height and so on. So you can then get what we call a laser cloud, and then we can take that cloud of all those laser points that have been reflected back. And then what we can do with software, we can strip all the vegetation that there's nothing left digitally. So we don't have to knock down the forest with chainsaws or anything like that. We can use a computer and we can strip the area that there's no trees, no grasses, nothing left except the ground surface and buildings and so on. And then we can look at small indentations on the ground surface that could indicate a shallow grave.
What?
And then we can use a ground penetrating radar. It looks like a lawnmower, and you move over it, and then it will send a radar signal through the soil. And because of the soils have different characteristics, it will bounce the wave back differently, and then you can see, oh, suddenly there's something not nice there. And then you can get the forensic pathology team in, and then they can exhume the body and do further analysis on it. So we can look for missing persons and things like that using LiDAR and the GIS and various algorithms to strip the vegetation, and then we can look at indentations on the soil, on the surface, and if it's rectangular shape, it could indicate a shallow grave.
Yeah.
Because after time the soil settles. So it leaves a distinct pattern, and then you can look at that. Other things you can also do with the GIS is you can map the river channel and look at vegetation and so on. And you can then use stream flow information together with the vegetation on the stream banks and so on to look at if a body is thrown into the river and the river transports it, are there any snags which can snag the body and so on when you start, and you know, most probably with information from witnesses and so on that the person was last seen upstream, and then you look at the possibility, was the body then moved downstream in the river, was it snagged by roots that's in the river and so on, then you can putting in the diving team to start looking for a body to retrieve it.
For example, there was that Henops case.
Yeah.
How would that?
There you would have applied those methodologies. See how deep is the river? Can it when the river is very shallow, it can't transport the body. Was the river in flood at that time when the bodies were chucked into the river and the vehicle? And then you can start looking at if the stream takes it downstream and there are snags and curves further downstream, there could be possibilities that the bodies could be snagged over there, and then you can start searching there for the bodies.
When you were telling us about GIS, you were talking about the Department of Geography,
yeah.
Right? But I'm assuming the forensics is a different...
It's one of the applications that you can use that tool for.
Oh, okay, fine.
Yeah.
So now we're trying to understand, because you
Yeah, sorry, I jumped around a bit, but GIS, the Geographic Information Systems, is a tool that I use to do all these forensic work with. And that's a software.
I think, oh, it's a software.
Yes.
And is it different types of apps, or it's just one thing?
It is, you get open source ones like QGIS, you can download it. You need a laptop for it. It is a proper software like MS Excel or MS Word. But you get also proprietary software which you have to buy, and some of them, the basic software is 2 million rand. So they're hideously expensive. But fortunately, these companies, especially Esri, they are very pro-educational institutions, and they give an educational license, as they call it, for the full suite for a fraction of the price to make it available to universities. So if you're a postgraduate student and a staff member at UNISA, you can get access to that kind of software.
Oh, fantastic.
We keep record of it because we want to know who uses it and so on. And also, if it's an educational license, you can't use it for consultancy work.
I was going to get there to be like, there's so many of these private investigators that we're seeing lately. How does that work then with especially the forensics? Because we're seeing almost like a gray area between what is legal, what is not. When we're watching this commission, we're seeing that people who are not qualified are doing your work, essentially.
If it's done legally, I don't think it's a problem. As long as it's legally. The thing is, with any forensic work, doesn't matter whether it's by a forensic pathologist at the police or at the hospital, a doctor that is doing a post-mortem, as long as it is according to the law. And in my case, when I work with cell phone data, I work together with the investigators from the police, because they get court orders, a Section 205 warrant. Then they have to serve the warrant onto Vodacom or MTN or Cell C or Telkom, and then they are because it's a warrant, they're obligated to release the information, and then they will give me the data plus the warrant, and I can work on the data and I can do the analysis for them and so on, and I even go to court and an expert witness on it and explain to the court how I did it and where did I get. But the thing is, because it's legal, the evidence trail can be proved, and so then the court does not take it into question. As long as it's above board and it's legal, and the data was acquired legally because of POPIA and all these other acts that protects people's private information, but because with a Section 205 warrant, we can then access that information. After that, if I don't get permission to use the information for an academic article and so on, I have to hand everything to the police.
One thing we were worried about, Prof, was when they said that even deleted messages on WhatsApp can be retrieved. Can you give us more information, unpack the cell phone analyses that you work on?
Okay, that's not my department.
Oh, okay, it's not that.
So no, what I normally work with is cold cases. So it means something happened 3 years ago, except the Talib Peterson and the Judge Makabela murder cases. I was directly involved immediately after the police started with the investigations, but normally I work on cases that are 2, 3, 4 years old, and they try to solve it, and then I start digging. And then they give me all the information and all that kind of stuff. I also work with private entities like law firms and so on to assist with them in arbitration cases and so on, which is based on the data that the police have, but then it is like 2 insurance companies are fighting now who's liable for the insurance payout of the stolen merchandise, for example, stuff like that. So then I get involved with them, but they also work via the police, and then the police releases the information to me, and then I can work with that. As I said, as long as it is all legal, and you can prove beyond reasonable doubt that you got all the information legally, your processes have been shown and proven, then the court does not take these things into question. Even the defense are also very reluctant to take on that kind of evidence.
And then you have worked on quite a few high-profile cases, and we're wondering if you can give us a story or two, and the background information and what you found out and then what happened, the drama.
Yeah, the one was the Talib Peterson murder case. It was highly published in newspapers and so on, so I can talk about it. Um, what we found out, and the detective and I, we worked together on the case. Unfortunately, he passed away a couple of years ago. But he and I, we worked very closely together, and what he did is he made a few phone calls from various rooms in the house. And as luck, and I put the emphasis on luck because it's not always like that, is that the house was on the border between 3 cell phone cells from 3 different towers. And depending on which room in the house you were, it would trigger a certain cell. So we could then prove that the person was moving through the house when the phone calls were made, contradicting the person's witness statement that the person was asleep.
Oh, what?
So we broke the alibi.
Oh, snap. And another one, you're not a very good storyteller, Prof, I must tell you, because we want to know, we want to be like, yeah, and then this happened, and then he did this, and then, oh my God. And so please, could you give us a bit more juice?
The other one that I worked on was a assassination case at Waterfront in Cape Town, where the sniper shot the person. And then could track the sniper's movements based on his cell phone records. How did he came to the waterfront? How he did the stakeout? Where was the best place to do a shot? We can also.
How did you find the sniper even?
The police fortunately arrested the guy very quickly, but we had to prove that this was actually the guy who did it, and we analyzed his cell phone data, got the locations, how he communicated with the guy that ordered the killing, and so on. Then we could put them together. And then we also could look at possible locations, looking at the angle of the shot, penetrating the window of the car into the skull. We can work out the angle, we can work out the distance back, we can then look at buildings in 3D around it, and then we can work out from which room the shot was fired.
Earlier on, you had said what works with you is that you've mixed that geography and the forensics.
Yeah.
What else can you mix it with? Or if somebody is kind of interested in this criminal area, how do they go about it? Which courses UNISA?
Police studies at UNISA offers various forensic science courses, and then they can specialize into various fields ranging from narcotics to jewelry to even art, stuff like that. To see they are people that specialize in these kinds of fields when they do try to get to stop people selling fakes and so on, or looking at art, high value art now, like Van Goghs and those things. Those people specialize it. When somebody says he's got a original, but then you start analyzing the paint, the chemical compositions of a paint, it doesn't match the paint composition, so it's chemistry and things like that. So you can also physics, where you use it how to work out the angle of the shot and all that kind of stuff, because the bullet drops at a certain angle and so on. So then you can trace it backwards using physics, and then you can work out from which window the shot was fired. You can do biology, you can do pathology, the human body, looking at traumas on the human body, organic chemistry for DNA analyses. So there's a wide variety of fields that you can study, which you can then apply in the forensic context. Like also with geology, you look at mining disasters and so on. You can then look at the geological formation. Did they oversee a fault line where the rocks were cracked, and then you had a sudden movement which caused the mine shaft or the tunnel in the mine to collapse, and it fell on people. Then you can retrace it and they say, was it negligence by the mine or not? In America, they used a geologist's understanding of rocks, but also cement composition and so on. And then they could find, there was a body found in a lake with a cement block on his feet. And then they could, there was a guy that was busy renovating his house, and he broke up the concrete floor, and there were concrete slabs lying around. Then they could link the concrete that was used to weigh down the body. That was part of the slabs that were there, because the chemical composition, the soil, and this type of gravel that was used in the concrete and so on matched with the concrete slabs there. And then they were asking the investigators some questions, and then it came out that this guy was irritated by this person, and then he killed him, and then he had to get rid of the evidence, and then things like that. Or war crimes, you can use it in war crimes where you look at DNA, blood samples, you can look at pollen, you can look at sand, so geomorphology, you look at soils and things like that, or pedology, soil science, where you look at soil composition. Soils are like fingerprints, they're unique to an area, whether disturbed or not disturbed. So you can then trace it back. What they did in Serbia, that was an article, they can then analyze the people were mass executed in a farm shed and then mass buried. Yeah. And then the end of the war in Serbia, the people who did these atrocities wanted to get rid of evidence. So they re-exhumed the people, dug them up, and then distributed them into various other mass graves to confuse the evidence. Yo. But what they forgot was when you shoot somebody, the person bleeds. The blood is sticky, so they could, and then the straw and the lucerne and stuff like that was in the shed, got stuck to the body. The blood wasn't yet dried enough when they were buried, so the soil and so on stuck into the body and clothes and so on. So then when they re-exhumed the bodies and they placed them at other locations, and when the investigators looking into these human crimes against humanity, they then could analyze the data, and then the soil samples taken from the body with the blood together, then you can separate it, then you can look at the soil composition. Is it silicon, is it aluminium, is it iron, is it cobalt, is combinations thereof, and then they could trace it back to the original mass grave because of the soil composition of that original mass grave, because they analyzed that. And then they, based on this type of straw and pollen and so on, and then they could work out in which shed they were executed in. What? And the dirt that was in the shed and so on. So that is how you can use soil science, you can use biology, you can use chemistry, you can use geography, various applications, sciences that are separate, but you can then employ it in a forensic context. So with chemistry, you can look at narcotics. Organic chemistry, you look at THC, that is the narcotic part of ganja or marijuana and so on, or cocaine and so on. But also interesting is cocaine and the THC and so on has certain trace elements in it which you can put to a link to a specific region where it comes from. What? Yeah. Because of the soil, the minerals that's been taken up by the plant is unique, and then it has an effect on the chemical composition of the THC or cocaine or whatever. And these are trace elements that you can use to link the dagga to a specific region. It's the same with opium, heroin, or all that kind of stuff. So also with mealies and vegetables and so on, you can actually work it backwards from which farm it came from and so on.
What?
So all these kind of information you can determine, and you can then apply it in a forensic context. The other thing was listeriosis, epidemiology, understanding the spread of diseases and so on, or contact tracing with, say, Ebola or COVID or the listeriosis problem that we had in in Limpopo province and so on, you can then start working backwards. The people got sick, but they still had a piece of polony left in the house. You take that polony, you do analysis with it, so it's organic chemistry and also food science comes into play in this instance. And then you can understand what's wrong, and then you can interview the people and might say, no, they bought it from this supermarket, and then you go to the supermarket, see who's the supplier of the polony, and then you can go to the people that make the polony, and so you can trace it back. Or in COVID or with Ebola, which were they call it contact tracing. So then they can say, okay, which people were the person that was ill or died of it in contact with, and then you go back from the point and so on. And so one person could infect 100, 200 people. And you need to find those people before they pass the disease on to somebody else. So this is epidemiology, or you want to trace back where did this disease originate from, like what they did with the AIDS virus. In the US, they found, in the beginning, AIDS was a lot with homosexual populations. I don't have anything against them, but that was very strong in the US especially. But then suddenly there was an explosion of AIDS in the heterogenic population, the normal families and so on. And then they start looking at people, but they were very good people. They didn't sleep around. They were husband and wife and so on. And then they looked at the polio vaccine. The green monkey, which comes from the DRC, is a natural carrier of the AIDS virus. And the first successful polio vaccines were grown on green monkey liver. So inadvertently, they took the AIDS virus with the polio vaccine, which is a lifesaver for a lot of people, but inadvertently, the dormant AIDS virus, because what they do is when they create a vaccine, they half kill the virus, not completely, so that your body can build the antibodies. The AIDS virus slipped through, and then boom. So with epidemiology, and you can then also use the geographical information systems where you can then start plotting the locations of these people, and then you can work back, okay, this was a polio drive in the late 60s or early 70s, and at these and these locations, and then you can start working from there to who could be possibly infected so that you can contact them and so on. You can then plot it and see where these people are, and then hotspots and so on, so that you can do then preventative medicine and so on. But then you can also go back in the history, which lab manufactured these vaccines, what did they use, where did they get the green monkeys from, and then they could trace it back to the Congo. But then also, unfortunately, Haiti, which is another country, has also a massive AIDS problem, because a lot of the people from Haiti originally originated from the DRC, and they were in contact with these green monkeys. They were bitten on things like that, so because of the saliva it carries over, and they inadvertently carried the virus, and then also boom, you get the explosion of certain illnesses. So that's all geography, but then with a very strong medical part. So what I was saying is there are lots, if you want to do epidemiology, you need to understand a lot of things about diseases and so on, but then you link it with geography to look at the locations where these things originate from, and you can backtrack and all that kind of stuff. So with the forensic side is the similar principle. Now you can start, okay, did somebody intentionally, knowingly infect a certain person? And where did the infection take place? case and so on, then you can use that in a criminal case against, because actually, if you intentionally knew you had a certain disease that is lethal, you actually used it to kill somebody.
Yeah.
So, okay, that's an extreme case, but it can happen. So then you can start building it around where did this thing come from and where did the person travel to, and look at the person's travel history, and you can map it. And then, okay, could have most probably picked it up there, and he knew, and he had a grudge against that particular person and infected the person, trying to hide it as murder, for example.
So I know you said it's not really your specialty. How would they work in kidnappings?
Yeah, kidnapping, if what you can do is you can try to, if they, you know where the kidnapping took place, normally from a CCTV camera or something like that, where the person was abducted, you can use that as a starting point. Then in the case that I was involved with, after the fact, when the guy was already released by the police, fortunately unharmed and so on, but traumatized. But then the people that were arrested at this crime scene, their cell phones were confiscated. I took them, the police got a Section 205 warrant, and they could download the data from these various call records and so on, and usage of internet from these cell phones. And that it was a Chinese nefarious organization that was kidnapping the Chinese national for ransom in South Africa. I'm not going to put the location in because I don't know exactly what was the outcome of the case. So, but what my part was, I could then trace back where the shop where those burner phones were bought, based on data that was recorded by the cell phone companies.
This is amazing. So you're saying every single crime has almost like a DNA footprint.
It has a footprint, we just need to find.
This is incredible.
And then a friend of mine who was a detective, a retired detective, he always told me, you must have a shelf. And each little evidence, cell phone evidence, pathology, whatever other evidence you have, and you take that little duck and you put it on the shelf. And then the next one, the next one, next one, next one, next one, and then you put a duck on the shelf, oops, there collapses the shelf. That duck that caused the collapse of the shelf, that's your entry point, and then you start with your investigation. And then you go back to all the other ducks that you found, where are the links and stuff like that. That's how you do it. And then a part of it could be cell phone records, and then they come to me, but look, we found that this duck that caused the collapse, the evidence, it was a cell phone, and there were some funny numbers on it, and so on, and then I can then they draw the data, and then they ask me to start analyzing those records, looking at the locations of the towers, who did talk to whom, and all that kind of stuff, and they start mapping it, and then with the other ducks, which are other pieces of evidence, does the cell phone corroborate it? And then that can be taken, like a witness statement says he saw the person at a certain location. Cell phone tower data says, yes, he was in that around that time. Okay, it corroborates, things like that. So you start building the whole puzzle together. And then if it's beyond, in South Africa, the law works as such, if the judge cannot find a person beyond reasonable doubt guilty, he won't find the person guilty. But if it's beyond reasonable doubt that the judge is beyond reasonable doubt convinced that this particular person did commit the crime based on the evidence put before him or before her, then the person will be found guilty and convicted.
Usually,
so when cases are thrown out of court, normally don't immediately say, but it's poor law enforcement and so on. There might be certain things which the judge found to his or her knowledge and integrity and experience and so on. This is not kosher. We can't use it. It will compromise the person's freedom, innocence, and so on, then they will throw it out. And will say to the person, sorry. But there are also other instances where maybe there was a mistake with evidence collection, and evidence trail couldn't be proved properly. And that's why for me is it very important when I work with cell phone data and so on that I have that Section 205 warrant as an evidence that they got the data legally, because when I go and testify in court, I tell the court, I got this data from Detective Sergeant so-and-so, or Warrant Officer so-and-so, or Colonel so-and-so, who was the lead investigator, and he gave me the data with the corresponding Section 205 warrant, and then I started analyzing it. Then the defense can't take me on that, and the judge is happy because the data was legal. So with other, also with forensic stuff like DNA and so on, was the process of collecting that DNA forensically correct? That means if you did a DNA swab, was it perfectly sealed? Was it sealed in a specific bag, time written on, who was it taken by, who was it taken from? All that must be meticulously noted down and so on, so that there is no cross-contamination or anything like that. Or even with soil samples, there's a certain procedure of collecting, and that you can study at the Police Studies Department and their forensic courses that they offer, modules. So it has to be collected in a certain specific way. So if the tool that you use to pick up the soil, like a plastic spoon, you put it with the soil sample in the sample case, you close it, you seal it, you write on it when it was collected, where was it collected, how was it collected, and so on. And then you seal that again, so it's a double seal, and then that will be taken to the lab and processed further. So there are, I mean, if you can't prove that evidence trail, then it can be taken into question.
You spoke about something so interesting. You said when the judge can't find sufficient evidence in the court, a case can be thrown out. But then there was this rule, especially with sexual assault cases, where the system said we can go back. If somebody rapes you 20 years ago, you can go back. But then how are you going to prove that?
Okay, if strictly speaking, any criminal evidence cannot be destroyed. It must be preserved. So the rape kit that was used 20 years ago, that data, the personal stuff that was collected from the victim must be preserved. So
you need that rape kit.
Yeah, so you have to go back to that rape kit or the analysis of that particular rape kit. So that might be destroyed, but the DNA analysis that was done on it and all that kind of stuff, that must not be destroyed. That must be available for, then you can go back in history. And some of these nefarious people might have a track record, and then you can go and dig backwards. How long was the person already been? That is such a nice oomie, he's so kind and so on, but meantime back at the ranch. And things like that happen. And so on, then you can trace back things and so on. Or with a serial killer, he works in a certain area and then the police starts to close in, then moves away to another area and lies down for maybe 5, 6 years or 10 years, whatever, and suddenly pops up again. Then you have to dig back and see what other evidence was there done before. So the evidence that's been collected, they might destroy the sample, but the results of the analysis, that may not be.
Sure, so that
destroyed.
rape kit is very important.
Yeah.
Huh?
So if you want more information about it, you must talk to a specialist about that to give you information on how these things are preserved and so on, which I don't know. I'm just speculating here, but I don't think I might be far out.
So, for different industries and professions, you need certain temperaments or certain personality characters or traits. What do you think is a good personality makeup for this area?
I really don't know. I just got
Really?
into my luck. I was working at the CSIR and the police came to me with the Marlies Holmes case where the girl was from South Africa and a boyfriend from the US, where they were kidnapped, abducted, raped, killed. And the police were asking for me, is it possible to map the phone calls of at that time, cell phones were not yet in so much use as it is today. But what they did is one of the gang members involved took the girl's phone and phoned his compatriots and so on, so we could then reverse engineer all that. And then they asked me, is it possible to map it? And I said yes, and that's how I got involved with it. But I must say, I got involved with the very terrible cases, and I ended up needing post-traumatic stress counseling. Yeah.
Oh my God.
So be prepared for that. So, but it might be my personality, I don't know about others, but some of these things are really horrendous. You don't see that in movies even.
What?
So then you have to go for counseling.
Okay, without it being too hectic, are you able to tell us some of the... Oh, it's too intense.
Yeah.
Yo.
Sorry.
No, I understand. I understand. Oh my gosh. Okay, so lastly now, so for a young person who wants to get into the space, can you give us the way in terms of the university?
If you're interested in forensics, I would recommend that you contact the Department of Police Studies at UNISA. And they've got forensic science modules and so on, but also police law and all these kind of things. So if you want to go the police route, if you want to go via medicine, you have to become first a medical doctor and then specializing in pathology and things like that. Or if you want to, from a geology or geotechnical, geophysical viewpoint, you must first do geology first and geophysics first, and then apply to forensics or geography. You want to do, there's not always crime. You also look at civil cases. In geography, you use a reach of supermarkets, for example, attracting people and so on, and then the one supermarket will fight with the other supermarket because it's stealing away the customers and so on. So you can use economic models and so on. So there are various ways and means. Like me, I got involved by looking at geographical patterns, and then from that viewpoint, so I did geography and mathematics as undergrad and specialized in geographic information systems. Did my PhD in that and all that kind of stuff. But my PhD is not about crime, by the way.
I was about to say, what's your PhD on?
GIS, data logistics, looking at how do you use logistics to get data for municipalities or anything like that. So I was more into logistics and so on, and got some interesting jobs out of it. I worked with the other colleagues that are also in logistics at the CSIR at that time, and we looked at the whole logistics process from the South African Defence Force, and when we staple yourself to an order. My part of the research was what happens with ammunition. So I went to the ammunition factory where they manufacture the ammunition, and then I looked at where do they get the copper from, where do they get the lead from, where do they get the brass from, where do they get the different powders that they need to make the gunpowder so that you can fire the bullet, where do they get the chemicals from, and then how it's been assembled at the plant, packaged, how does the South African Defence Force get it, at which location they offload it, and what's the auditing processes involved, and then how do they split it, which ammunition goes to which company not in the sense of a business, but a group of soldiers. How did they go to infantry schools or infantry training centers or wherever, what they and I followed it then. We had been shipped to the peacekeeping forces in Africa. I went to Burundi. We talked to the soldiers there, right up to where the shot is fired.
It's so amazing because...
So, but again, it has lots of geography to it, because you need to know where the minerals, where the materials come from, where it's been assembled, how does it be, which routes are being taken to being shipped to the ordnance depot. Ordnance depot is located at a certain location. Then you map that. And then you map where it's taken to Waterkloof Air Force Base because it's a military thing, and then it's been taken to Burundi, where they land in Burundi, how do they collect it at the airport in Burundi, where did they go to the South African bases, now it's then been distributed to each soldier.
I think what's so incredible...
So that's geography and logistics comes also nicely together. But you can also look at then, from a forensic viewpoint, is looking at how drugs are moved. And where it's been grown, where it's been processed, where it's been packaged, where it's been taken to at the location in, say, South America somewhere. How does it get onto a container to South Africa, where it's been offloaded in South Africa, where it's been then shipped to Europe, so you can then work out the drug route. Where it's been shipped, and then you can start mapping it, and then you can start interfering with it. So this, as I say, forensics is very wide, but you have to have maybe study something else like geography or medicine, being a doctor, or chemistry or geology or physics. You have to study that first to know how you can then apply it in a forensic context.
And there has been a scourge in drugs lately.
Yeah.
So what's happening?
So what you can do is, what you can analyze, if the drug mules that you arrest, they can give you evidence. Where did they get from? Who contacted them? Where did the place took place where they come? But you have to also put them in witness protection, because these guys you don't play with, and so on. So there's a lot of things you can do, actually, with anything that you study. In psychology, you look at psychological profiles of criminals or serial killers, for example. So you have to have a master's in psychology first, and then you can specialize in criminal. You can study criminology, you can then apply that. So there's a wide variety of things you can study. It's not just geography, it just happens to be my field of expertise, and I apply it in a forensic context. But you can also use it for civil arbitration cases and so on, or insurance fights, or helicopter crashes, or aircraft crashes and so on, where you can look at the crash location. You can then take aerial photographs of the wreck, how did it impact onto the ground, things like that. Then you can start digging back from where did the aircraft originate from, the last flight. Then you can work backwards, the work packages that was done on the maintenance of the aircraft, that somebody didn't do something which should have been done, negligence. So that's a civil case, it's not a criminal case. So you can also use it, you can use it in civil cases as well, not just crime cases. So yeah, as I say, it's wide open. Environmental criminal crimes, you can also use GIS with satellite imagery, looking at illegal peat mining, for example. And then you can, with the tools that you have available, you can work out the volume of peat that's been mined, and you can look at the environmental damage. Then you can decide, okay, you put that to court to see how that progressed over time and how much was taken out. And then you can also look at, is it possible to rehabilitate the area or not, for example. In some instances, the damage is so big, sorry, it can't be rehabilitated, but you can repurpose it then, for example. You can also look at illegal dumping of certain nefarious substances like uranium or silesium. What you do is you have an aircraft or drone, and it has a, if you look for uranium, you can use this Geiger counter, and as you fly an area, it will pick up the radiation, and you can get the location, and then you can look at hotspots and so on, and there could be illegal dumping of uranium, for example, or silesium. I was a student geologist on our gold mines in South Africa. The gold mines and uranium, gold and uranium goes together, and then we do core logging, exploration work, and you get these meters and meters of core logs, and we're too lazy to look at each little part of the core log. Does it have a specific rock in it that looks like a fingernail? It's a certain leader geology to a reef or something like that. Or you just take a Geiger counter. Okay, here's the Gulf. Here's the gold reef. And the Geiger counter says there's uranium, there's gold. There's a gold.
I can see your inside your passion
kind of
now.
geology there, you know?
Yes. Yes,
So,
thank you.
Awesome.
Thank you, Prof. This has been so... You know what's amazing about this conversation is that when we see you guys in the streets in your blue uniform, we actually don't realize like how knowledgeable and how deep what you're doing is.
I was never a policeman, but I work with them a lot, and
Yes.
I've got lots of respect for them.
Right? Such important work. Thank you so much.
You're welcome. Thanks for inviting me.
Oh, pleasure. So there you have it, guys. We are in a war right now with evil, so we do need people to get into this department and come and clean up our country. Please do check out the UNISA website and check out other courses as well. We will continue with this program where we bring you different professors in different departments so that we can find ourselves, so that the future looks a little bit better than it is. We'll see you again next time.
Who are you when all you were has been diluted by lies and white lines cancelling out all that which has been written of your history? Why do you look at yourself as a mystery? Doesn't the sun shine because you open your eyes? Doesn't the moon stay situated within the same stars your DNA sparkles off? Your spirit knows that surely corner into e off. Buza umoya so you may return to being well off. Because spiritually you are rich, yet your ancestors cry because you are out of reach. But yours is to command all elements while God takes inspiration from the very mirror she looked at to become. Remember who you are and never finish just when they think that with you they are done.